Graphing linear inequalities in slope-intercept form. Graphs of inequalities are similar to linear equations in that they both have points on a coordinate plane that are connected by a straight line. The difference is that a linear equation is represented by only the line and the points, but an inequality includes many more points that are not on the line. We'll start by comparing a linear equation with an inequality that has the same look, with the exception of the inequality and equal sign. So if the linear equation is y equals mx plus b, the inequality will start out as y is less than mx plus b. The linear equation is graphed on the left. Here we have y equals x plus 1. The inequality is graphed on the right. The solution set for the inequality includes only y values that are greater than x plus 1 and is indicated by shading above the line of y equals x plus 1. Unlike the linear equation, the line is dashed, indicating that the inequality solutions are not on the line. So because this is not a greater than or equals to, it's just greater than, it is a dashed line, sort of like an open circle versus a closed circle on our one-dimensional graphs. The shaded area is called a half plane. Instead of shading the half plane, you can also use arrows to show that the solution set is greater than that line. This unit, however, will mostly use shading. For the inequality y is less than x plus 1, the half plane is below the line, indicating the location of the members of the solution set. For both graphs, the lines extend to positive and negative infinity. The dashed line is replaced with a solid line when the solutions are also on the line. This is when we use greater than or equal to or less than or equal to operation instead of just greater or less than. So here we have y is greater than or equal to x minus 1, and here we have y is less than or equal to x plus 1. How to graph a linear inequality. First, solve the inequality for y. So for example, y is greater than 2x minus 1. Decide where the boundary line goes. The boundary line is the graph of the equation that is similar to the inequality. So essentially, if you just set this equal to an equal sign, then it's just y equals 2x minus 1. That's your line. Then decide whether the line should be solid or dashed. If it's just greater than or less than, it's going to be dashed. If it's greater than or equal to or less than or equal to, it will be solid. Then we're going to graph that line, y equals 2x minus 1, and that will be, in this case, a dashed line, since there's no equal sign here. Then we decide whether to shade above or below the line. So because this is a greater than symbol, we will be shading above the line. You could also just test a point and then shade the side which has a solution. All right, here's an example. Graph y is less than negative 2x plus 1. All right, so this inequality is already solved for y, so we can move to the next step. The line is going to be dashed because it's less than, not less than or equal to. So we go ahead and we graph the line, negative 2x plus 1, and we create it with a dashed line. Then because it's less than and not greater than, we shade below the line. Graph 2x minus y is less than or equal to 4. Step 1, solve for y. So first we're going to subtract negative 2x to the other side. Then we're going to divide by negative 1. When we divide by negative 1, we will flip the inequality. So it becomes y is greater than or equal to 2x minus 4. That means the line is going to be solid because there is that equal to option here. So we're going to graph y is equal to 2x minus 4. So we go down to negative 4. Then our slope is 2, so that's up 2 over 1, up 2 over 1. We draw a solid line since we have that equal sign here. And because it's greater than, we shade above the line. Graph y is greater than 1/2 x minus 2. The inequality is already solved for y, so we move on. The line is going to be dashed because it's greater than, not greater than or equal to. We're going to go ahead and graph y equals 1/2 x minus 2. So our y-intercept is down at negative 2. Our slope is up 1 over 2. And then we're going to shade above the line because of the greater than operation. The methods of how to solve and graph inequalities, both on a number line and in the coordinate plane, have been covered in this unit. It is time to apply these methods to everyday problems, such as purchasing items at a store within a budget and earning money through various jobs. At a department store, dress shirts cost $12.50 each, and each pair of dress pants cost $25 each. You have $125 to spend. Write an inequality that would be used to model the situation, graph the inequality in a coordinate plane, and list 3 combinations of dress shirts and pairs of dress pants that could be purchased within your budget. Let X represent the number of dress shirts and Y represent the number of pairs of dress pants. The cost of the dress shirts is $12.50 times X, the number of shirts. The cost of the dress pants is $25 times Y, which is the number of pants. The dollar sum of the shirts and pants must be less than or equal to 125. So we get 1250x plus 25y is less than or equal to 125. Now we're going to graph the inequality. So first thing we need to do is solve this for y. So we'll subtract 1250x to the other side. We'll divide both sides by 25, and we get y is less than or equal to negative x over 2 plus 5. Because it has the less than or equal to sign, it will be a solid line. We're going to graph the line y equals negative 1/2 x plus 5. And then, because it's a less than sign, we're going to shade beneath the line. List 3 combinations of dress shirts and pairs of dress pants that could be purchased within your budget. So we can choose any ordered integer pairs that are in the shaded area of this graph. The x component of the pair represents the number of shirts, and the y component represents the number of pants. Here are some sample answers. 0, 5, so we could have 0 shirts and 5 pairs of dress pants. We could have 4 shirts and 3 pairs of dress pants there. We could have 6 shirts and 1 pair of dress pants. We could have 2 shirts and 4 pairs of dress pants. Actually, any of these, right? You could have 2 shirts and 2 pairs of dress pants. You won't have reached 125, but you could still buy 2 of each, etc. At a sports shop, soccer balls cost $22.50 each and footballs cost $15 each. You have $90 to spend. Write an inequality that would be used to model the situation, graph the inequality in a coordinate plane, and list 3 combinations of soccer balls and footballs that could be purchased within your budget. Let X represent the number of soccer balls and Y represent the number of footballs. The cost of the soccer balls is $22.50 times X. The cost of the footballs is 15 times Y. The dollar sum of the soccer balls and footballs must be less than or equal to 90. So 2250x plus 15y is less than or equal to 90. To graph the inequality, first we solve it for y. And we get y is less than or equal to negative 1.5x plus 6. The y-intercept is 6. The slope of the line is negative 1.5. We draw the line, and it is a solid line because there's a less than or equals to sign there. And because it's less than, we shade in the area underneath the line. List 3 combinations of soccer balls and footballs that could be purchased within your budget. Any integer coordinate pair here would work in the positive domain, of course, because you can't have negative soccer balls or footballs. 1, 1 would work, 2, 1 would work, 3, 1, 2, 3, 1, 4. Any of these points would work.